Hello there again. Now we're going to talk about derivatives of log functions. And actually I'm going to start with, we always start with the derivative of the natural log function. And the reason is because any log can be rewritten as a natural log. So let me go ahead and give you the derivative. The derivative for just the natural log of x with respect to x is simply 1 over x. So if you have to find the derivative of natural log of x with respect to x, that's 1 over x. So an example of that, I'm just going to give you one example here. So here I have y equals x squared minus natural log of x. So to take the derivative of that, I take the derivative of x squared, which of course is 2x, and then minus the derivative of natural log of x, which we now know from this formula is 1 over x. So the derivative would simply be 2x minus 1 over x for that one. But we're going to give more focus on to this formula here. Whoops. But so rather than focusing on just natural log of x, let's talk about if the argument of the log is u, where u is a function of x. So instead of natural log of x, suppose we have natural log of x squared, or natural log of sine x, or natural log of e to the x, and so forth. So here the derivative for natural log of u would be 1 over u times u prime, and du over dx is the same as u prime. So 1 over u times u prime. So now let's take a look at an example here. If you take a look here, you'll see I have y equals the natural log of this trinomial 3x squared minus 5x plus 1. So based on this problem, the first thing I'm going to do is just write 1 over. So there's 1 over that trinomial. So whatever this is u. So the derivative of natural log of u, where u is this trinomial, would simply be 1 over u. So 1 over that trinomial. But then don't forget, you have to multiply, because of the chain rule, you have to multiply by u prime. So now I have to multiply by the derivative of this. Now down here I'm just showing you that I'm going to take the derivative of 3x squared minus 5x. That's that fixing to notation there. So now, could I have gone ahead and just taken the derivative in my head right here and just went ahead and put 6x minus 5 here? Sure, I could have. But I just want to make sure that you see that I'm going to take the derivative of the argument of that log, and the derivative of 3x squared minus 5x plus 1 is 6x minus 5. So you have 1 over this trinomial times 6x minus 5, which you can just write as 6x minus 5 over 3x squared minus 5x plus 1. So actually another way to write this, let me show you another way to write this formula. So another way to write 1 over u times du over dx, or 1 over u times u prime, is simply just u prime over u. And if you'll notice here, that's what I have. This is u prime, and then this is u, so I just have u prime over u. Alright, let me work number 4 here next, because I want to stay with this theme here. So if I wanted to find the derivative of natural log of x to the 4th, the rule says the derivative is 1 over u, so u is x to the 4th here. So the derivative would be 1 over x to the 4th, and then times the derivative x to the 4th. Okay, well, the derivative of x to the 4th is 4x cubed, so I have 1 over x to the 4th times 4x cubed. And then since x cubed over x to the 4th is just 1 over x, that ends up being just 4 over x. And actually on this one, you could have used a log property and rewrote this as 4 times the natural log of x, and then just taken the derivative that way. But so that would have been just 4 times the derivative of natural log of x, which is 4 times 1 over x. Now this next example I want to show you is actually a general power rule problem, because it's actually, I have a function to the 4th power here. So to take the derivative of a function to a power, I use the power rule. So I would have 4 times the function natural log of x to the 3rd power, but then remember the power rule, you've got to multiply by the derivative of the inside, so I'd multiply by the derivative of natural log of x. So finally, I bring this down 4 times the natural log of x quantity cubed, and then the derivative of natural log of x is 1 over x. And so 4 times the natural log of x quantity cubed times 1 over x is the answer. Or if you wanted to, you could write it like this: 4 times the natural log of x quantity cubed all over x. Now this next one here, I actually have a product, x squared times natural log of x, so I'm going to use the product rule. So remember, the product rule says you take the first function, which is x squared, times the derivative of the second, which is the derivative of natural log of x, would be 1 over x, and then plus the second function, which is natural log of x, times the derivative of the first function, so the derivative of x squared would be 2x. So this would just be x squared times 1 over x plus 2x times natural log of x, and x squared times 1 over x is the same as x. So you can write the derivative as x plus 2x times the natural log of x. And then this other one over here is actually an example of a quotient rule problem. And if I remember right, there's an error I might need to correct, but we'll see it if I get to it. Okay, so this is the natural log of x over e to the 2x. So this is a quotient rule. So I'll let u be natural log of x. I'll let v be e to the 2x. So using the quotient rule, I would take v, which is e to the 2x, times the derivative of u. So that would be the derivative of natural log of x, which we know is 1 over x. And then minus u, which is natural log of x, times the derivative of e to the 2x. Now remember, the derivative of e to the 2x is what? It's e to the 2x, and then times the derivative of 2x, which is 2. So that's where that 2 comes from. So again, the derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. Okay, now what I did here, what I wanted to do, you see this fraction I have right here, 1 over x. So what I wanted to do is I wanted to multiply each term by x so that I could get rid of that fraction. So basically all I did here was I multiplied every term on the top by x, and I multiplied every term on the bottom by x. And then when I multiplied 1 over x by x, they just cancel, so I just get e to the 2x. And then when I multiplied natural log of x times 2e to the 2x, okay, first of all I'm going to put the 2 right here, and then when I multiply it by x, that's where I get that x from. And then I've got natural log of x, and I've got times e to the 2x. Now the last thing I did here was I went ahead and factored out, I factored an e to the 2x out of this. So if you factor an e to the 2x out of this, you get e to the 2x times 1 minus 2x natural log of x. Now, it turns out that e to the 2x will actually cancel into e to the 4x and give me e to the 2x. So my final answer is just 1 minus 2x times natural log of x over x e to the 2x, and that's your derivative. Okay, I wanted to show you this with a trig function in it, and so if you take a look at this, even though this has a trig function as the argument, it actually still is in the form of natural log of u. So this is natural log of u where u is cosine x. So the derivative of this, using the log rule, the derivative of natural log of u would be 1 over u, so it would be 1 over cosine x, and then multiplied by the derivative of the argument. So the derivative of cosine x is actually minus sine x. So I'm actually going to multiply this 1 over cosine x by minus sine x, and I'll get minus sine x over cosine x, which is actually the same as minus tangent x. Now this other one here, this is actually a trig rule. I need a trig rule on this one. So the trig rule, remember I have here, I have y equals secant of u. So this is secant u. So what's the derivative of secant u? If you go back and look at your formulas, the derivative of secant u is secant u, which is this, times tangent u, which is this, but then you have to multiply by the derivative of u, and what's our u in this case? Natural log of x. So multiply by the derivative of natural log of x, and now what's the derivative of natural log of x? 1 over x, right? So if you take this and multiply it by 1 over x, you'll just get secant times secant of natural log of x times tangent of natural log of x all over x. And so that's your logs involving natural log. That's how you find derivatives that involve natural log. Now, logs don't have to be the natural log form. You remember the natural log has base e. But what if my log has another base other than e? So what if I have a log where I have the base of the log is some other base other than e, say base a? Well, if you just want to take the log of x base a, the formula for that is 1 over natural log of a times 1 over x. So, for example, if you wanted to take the derivative of log of x base 2, then the derivative of that would simply be 1 over the natural log of whatever this base is, in this case 2. So it would be 1 over natural log of 2, and then you'd multiply that by 1 over x. And then if you put those together, you get 1 over x times the natural log of 2. Well, as you probably guessed, if we have the log of u with a base other than e, then we have a formula for that too. So the formula for this, the log of u base a, that's 1 over natural log of a times 1 over u times u prime. So if I wanted to find this, well, the derivative of this would be 1 over 1 minus x squared, right? And then times 1 over natural log of 5, and then I'd multiply by u prime, which is the derivative of this. So that would be, it would be 1 over u times natural log of 5, because 5 is the base, and then you would multiply by the derivative of 1 minus x squared, which is minus 2x. Okay? Now, here's another one. This one is log of this polynomial base 5. So the derivative of that would be 1 over this polynomial. So there's the polynomial in the denominator. And then also in the denominator, I'd have natural log of 5. And then I would multiply this by the derivative of 3x squared plus 5x minus 1, which is just 6x plus 5. So that's how we would get the answer there. Now, on the next one, I actually have log of a trig function, so the log of tangent x base 7. So this would be 1 over tangent x times the natural log of 7, and then multiply by the derivative of tangent x, which is secant squared x. So if you take 1 over the natural log of 7 times tangent x, and then multiply it by secant squared x, which is the derivative of tangent x, then you'll get secant squared x over natural log of 7 times tangent x. And, you know, I don't know if these trig functions here will simplify to something nicer or not, but I'm just going to leave it like this. Okay, so that's pretty much how you find the derivatives or differentiate log functions. And so we're going to move on to another type of function in the next video, and we're going to talk about how you differentiate inverse trig functions in the next video.